Okay, welcome everybody. We'll get started here in just a second. I just want to make sure I'm letting everybody in. Okay, I think we can get started. It's 9:01.
Awesome. All right, Cole. Great. Well, welcome. Oops. Now I'm looking at the wonderful Sarah.
Oh, you should be seeing everyone, I hope.
Okay. All right, great. Welcome everybody. Good morning. Hope everybody's having a good week. Happy Thursday. Looks like a few more people to admit on the Zoom meeting. We are excited to do virtual brew. I think we can jump right into the next slide, or to the first slide, Cole. Thank you. Well, I just welcomed you, so I went ahead. Sorry. All right, so we're going to talk a little bit about what's happening at AI, and then the main content for today's meeting will be Andrew Worcester talking about digital voltmeters and PCS field data collector and Android and calibration. I think it'll be a really, really good topic for anyone who not just uses our digital voltmeters, but maybe uses other type of field instrumentation. You probably will be able to take some of that knowledge and apply it there as well. So ready to jump in. We are fresh off a great week in Austin. We had what we used to call users group meeting, and old people like me still do. And now it's called AI World. I got several emails from companies wanting to sell me things around artificial intelligence after our show last week, but we had a great time. This was probably for many of us, this was probably the worst part of the whole week. We had to stand in front of a camera taking pictures from us. It was a really professional photographer with a neat drone. We had a great time. We had probably, with our partners and customers, close to 120 people there at any given time. And we had, I think, 31 people come for the very first time, which was awesome. And we've gotten some great feedback about what went well and what we can do better. We always appreciate that. Probably the biggest single piece of news at the show was that we announced what we're calling the 5 series remote monitor, RM5. And so if you're ever feeling kind of down, you should go find a video of that introduction, because if you wrote a script about what to go wrong during a new product introduction and you search that, that's what would show up. So first the projectors froze, and then when we got that fixed, the computer decided to reboot and start doing Windows updates. And so then I said, okay, no more computers. We had a rectifier on a stand. We had the new RM5 cellular monitor installed, and then I proceeded to rip the power supply apart in front of everybody, not once, but twice. So everybody was a good sport. The folks there were very, very forgiving. But it was really exciting, and we got tons of questions, and we've already had people place orders for it, and we're really, really excited. It's the first product in a series of products. The next product will be a satellite rectifier monitor, and then we are going to be doing low-cost test point and bond monitors, and we have a lot of exciting things for 2023 that will be built on that same platform. So it was a super exciting week. We got, as I said earlier, we got a lot of good feedback, and one of those feedback is always about the availability of training resources, not just classroom training, but also videos that could be accessed either in the field or in the office. And so we mentioned, I think last month, maybe the month before, maybe both, that we have a new website, and one of the focus areas of that website was to make it really easy to find product training and support content. So Sarah, keep an eye on those admits. I think we still got people bumping in and out. Cole, the one thing you and I didn't talk about is are you gonna go to the website for me for the training piece? So if you look at the website right there, that's kind of our home screen, and right at the top you can click on product training and support. I'm sure I can share my screen if you'd like me to. You want me to do that? Yes? Okay. All right, let's see which one we're going to share. All right, share. Great. All right, so this is the website. You can click on there, and then that's our, can you guys all see the screen now, the website?
Yep, that's great. Yes.
Okay, so if you call AI, there's the customer service team. I don't know why they have the Texas A&M Aggie thumb up, but I'll have that fixed by the end of the day, I assure you. But really, there's a lot of really good content here. I really encourage you. I don't know if you're like me. I try and self-serve whenever possible, but you can get on-demand training. We have highlighted videos. Not sure why my pictures aren't showing. That's probably my fault. But this is really professional quality videos. Here we go. So these are just the ones that we're featuring right now, but it's technical in nature. For instance, how to take a pipe to soil reading with an Allegro. There's a whole series of them. AC interference on a Micromax interrupter, GPS receiver technology, instructions. You get it. It's and this is growing. I won't say it's growing every day, but I'm certainly telling you it's growing every week. There's a lot of good content. We have a team of people focused on this now, and we intend to invest more and more in this training site and obviously also the technical support team. So that's really what we wanted to focus on. We wanted to talk a little bit about AI World. We wanted to talk about the RM5, which is going to be the focus of next month's virtual brew. And then I wanted to show you some of the training and video resources. I hope somebody's monitoring the chat, or maybe those are just our chats. Oh no, it's Vince being obnoxious, saying gig 'em. Terrible.
We will do a more in-depth technical overview of the training at one of our upcoming virtual brews soon.
Yeah, February. It's really, really important. You guys give us feedback on that, and we really do listen to it. The user group meeting largely has been shaped around feedback since we've been doing it for so long, and we keep tweaking it and trying to make it better and better. So I think with that, I'm going to stop sharing. I'm going to turn it over to Andrew Worcester, who's our product manager for all things mobile, which includes PCS FDC, which is our mobile software and hardware, and Micromax interrupters, and the soil resistivity meter, and anything else he dreams up.
Thanks, Ed. Yeah, I guess you took care of my introduction. So yeah, I'm Andrew Worcester. I'm the product manager for all the stuff that Ed mentioned, all of our field data collection products. So I'm going to walk through a few things on what we've got going on right now with field data collection, some upcoming dates that are going to be important for especially.
Okay, looks like you just froze up, Andrew.
It's because I'm in the meeting now. I'm cursed. Well, let's let him get that fixed, and we'll head right to the next slide, and I'm going to jump in and make it up as I go. You guys are all used to that. Oh, are they his slides though, Cole?
I got it.
Okay. All right. So what Andrew was going to say more eloquently was when we first launched our new mobile solution, it was exactly 2 years ago this month. And if many of you remember, the product line was called Cartopack Field Integration, and the suite of apps that our cathodic protection clients were using was called Cartopack Cathodic Protection. Very original name on that one, right? Well, we tended to confuse people a little bit by that. When you called for tech support and you heard the word Cartopack, you'd hit that. And we also have a group in Fort Collins, Colorado, that really focuses on. I'm going to let you guys stay on top of the chat. Okay, I'll keep going.
Yes.
Please. Anyway, it caused a little bit of confusion. So. Because integration with PCS is really the central value, one of the central values of our mobile solution. We've put that under the PCS name now, so it's real clear. If you call in for questions and you have a question about Survey Manager, you have a question about PCS, the compliance software, or you have a question, for example, around our new mobile solutions on Android and iOS, you just select PCS and you'll be directed to the right person. And so that was one of the big things we did in the latest release. It's the 14th release we've done since we introduced the software 2 years ago. So it's a little bit better than every other month, somewhere between 6 and 8 weeks. So the renaming is probably a bigger project than all of you care to know. But we also improved the wireless syncing between PCS and this PCS field data collector. It eliminates manual file transfers, and it allows you to actually visualize and monitor your surveys in real time. So what that means is you can go out and collect data, and if the person doing the survey has an internet connection, they can push that data into the cloud over Wi-Fi or cellular, and maybe somebody back in the office can actually look at the data, make sure it's correct, and there are no issues with the survey before it gets pushed into PCS. So that's what I think he was going to say on this slide, because so Matt mentioned other people are having trouble. Are we in good shape in general? Yes, Matt, nod if we're okay. Yep, okay. You can see the AI hat wobble, the bobblehead. All right, next slide, please.
I think so there's 36 people on. I'm hoping that we're good.
All right, is Andrew back on by any chance yet? No? Okay, well, you guys are in luck. So this is a great
connection. He'll be right back.
This is a great, I'm probably the only one from the AI side that was here. That's not true, but we've gone through a lot of generations of the Allegro. I'm willing to bet that some of you on the phone, on this Zoom call, have used or maybe even are still using something prior to the one on the left. It was called the Allegro CX. And we will send a gift card to anyone who can tell us what the model was before the CX. And no Googling on the Juniper website or anything, but there was a model before the Allegro CX that people used to take surveys. So that I'm blanking on the name right now, so you could pretty much say anything and it would probably be right. But we'll monitor the chat if anybody comes up with that. But we've had the Allegro MX, which used that what's called, you guys probably forget this, PCMCIA, that slot that used to exist in the side of your computer, digital voltmeter. Then we released the QX about 6-7 years ago. That's a good guess, Nick. I'll have to check. I saw the chat, but good for you for putting one in there. Thank you. Oh, Hamlin's on the call. I forgot. He'll know. He's not eligible for the gift. The QX we released, I think 6 or 7 years ago, at least. The AX was released 2 years ago when we released the new software for Android, and then the Mesa 3. The AX and the Mesa 3 came out at the same time. Each one came with a new generation of a voltmeter. The patented measurement technology started in the QX, and we've carried that forward, right? And really since. Oh, Andrew's back. Okay,
I'm
let
back.
me finish this.
Sorry,
slide.
I didn't want to interrupt you.
I'm hot on this slide.
Of course, it would happen right as I go to say my first word. My internet connection would drop. So,
well, with any consolation, you want to jump in?
Yeah, if you don't mind,
let me finish.
I'll take over from here. So,
okay, I already went through all the models. I explained the different DVM models. So,
okay, great, great. So,
and then let me say one more thing. The DVM 1110 is a slight tweak on the previous one. It works with the AX, and then the main difference between the 1110 and the 2130 is we added Bluetooth and a battery to the 2130, but all the measurement capabilities are the same between the 1100, the 1110, and the 2130. Now I'm done.
Thanks, Ed. I think you covered the exact same things I would have said there. So I'll pick up from here. So talking a little bit about the evolution of the field computers. Now I want to hone in a little bit more, and if I can control the screen, here we go. Want to hone in a little bit more on the DVM itself. And one of the things that makes the DVM what it is, that allows it to perform the way that it performs, is calibration. And this is not something that's unique to our DVM. This is something that's used for most measurement devices that are out there, most electronic measurement devices or non-electronic measurement devices. And so I want to walk through a little bit about calibration. First, what is calibration? Well, let's start by kind of going back to the basics around this, and let's look at the cesium atom. So the cesium atom is pretty special in the world of calibration. This atom, like all atoms, emits electromagnetic radiation. And the waves that come from this atom are at a frequency, a special frequency that can be tied back to the amount of time in a second. So the cesium atom and its waves and the frequency that they are emitted is the standard reference for the second. And all atomic clocks in the world are basically measuring cesium atoms and the waves that are emitted from those. In fact, at a level of accuracy so finely tuned that the error is like 1 second missed over the course of 1.4 million years. So it's a pretty darn good reference, pretty good standard. And the second, like all other physical phenomenon, natural phenomenon that can be measured, everything has some standard, some reference that we can go back to and say, yeah, this is a volt, this is an amp, this is, whatever standard that you want to, whatever thing that you want to measure. So within the US and other countries as well, but within the US, there's actually a governing body that keeps a library of all these standards, and all the devices that you use in the field can be traced back to those standards. And that governing body is called NIST, or the National Institute of Standards and Technology. So really, what is calibration? Well, it is a process that ensures that your instrument is accurate, that it meets its published specifications. And the way that we do that is we compare the difference between what your device measures to a traceable standard. So when we calibrate, when you send in your DVMs or your other devices to be calibrated by us, or when you send devices to a third-party calibration house to be calibrated, we don't ship it to NIST and them do the calibration. What we use are traceable standards. So this device that you see here on the right, this box, this is a Fluke calibrator. It's actually a Fluke 5502A calibrator, and it generates voltage. It generates current. That voltage and current that device, that box generates, is calibrated and can be traced all the way back to NIST. So we're basically using a transfer of the NIST laboratory on our production floor. And when you send your device into us to be calibrated, that's the device, that's the box that we use to calibrate your DVM. And because that box can be traced all the way back to NIST, any DVM that is calibrated with that box is calibrated to the same standard. So you can trust one DVM relative to another DVM that you take out into the field. Why do we have to calibrate? So it's all great. That's how it's done. That's the process. But why do we ultimately have to calibrate your instruments? Why do you have to send them in? Well, it all relates to change. And there's a number of things in the world that can cause your device to change. Temperature, as temperature fluctuates as you're using it in the field, particularly in using them for surveys for cathodic protection, there's a lot of temperature swings that can happen depending on where you are or depending on the time of year. Contaminants or moisture, if things get onto the electronics, it can influence how they age or how they perform. Time. So really kind of the overarching thing here is an electronic instrument like a DVM has electronic components on it that is made of materials that change over time, that change with temperature, that change with vibration or shock. And calibration is a way to account for those changes that happen. Now, we do some accounting for those changes that could happen when we design it. So temperature and all of these factors, we pick components that can tolerate a wide range of change that can happen from any of these conditions that you see on the slide. We design our plastics to withstand or to have protection, ingress protection from contaminants and moisture, so that is less likely of a factor to change your device. But ultimately, all of these factors, and there's probably many more, but these are kind of the big ones. These are the factors that cause change to your instruments, and that change has to be kind of reset on an annual basis to ensure that your device functions the way that we publish it on our spec sheet. So I already touched a little bit on the how. Like, we've got our Fluke calibrator, and it generates voltages that the measurements of your device are verified against the published specification. So we, if we want to check how well does your device, how well does your DVM measure 1 volt, we tell the calibrator generate 1 volt, and we look at what the reading is. And that reading is then used in one of 2 ways. So there's, generally speaking, 2 different types of calibration. One of them is called verification and adjustment, and the other one is called verification only. So in verification and adjustment, well, actually, in both cases, devices that fall under both of these categories will usually have internal software, also referred to as firmware, that contains calibration constants. So if I say, hey, if I measure I look at the measurement of my DVM and it says, I'm measuring 1.0001 volts when I'm telling it I'm giving you 1 volt. That's a 0.0001 volt offset error. And so there's a constant, a number that's stored in the DVM that says, hey, we need to subtract 0.0001 volts off of the measurement before we deliver that to the user. That's called a cal constant. And so in the case of verification and adjustment, your DVM takes a reading, delivers us that reading, and then we go into the device and make adjustments to those calibration constants, because change has happened to your DVM and those constants need to be changed accordingly. And so all of our DVMs fall under this category of verification and adjustment, where change is happening to the cal constants as a part of the calibration process. There's also a verification only. Some devices are designed or have specs that may be pretty wide, and that's a suitable thing for whatever you're using it for. You just want to make sure, is it operating to the published spec? And one device that we have that's like this is our soil and resistivity meter, the SRM 100. It is a verification only check, where we measure and we provide that on a report, and we say, yep, it's still operating the way that it should, but we don't go into the insides of it and change cal constants, because it's designed kind of with a lot of headroom. The DVMs are much tighter and provide a much more accurate measurement for that given application. And on the right side there, when you send your devices to us, when you send them to third-party cal houses, we will generate and provide you a calibration certificate when we ship that device back to you, so that you have record that, yes, I calibrated my instrument, and this is what it was measuring. It says right here that it's traceable to NIST, so that if one of my auditors asks, yes, they have calibrators that can be traced back to NIST. Here it is, and you're good to go from there. So on the topic of calibration, there's an important date coming up that we relayed earlier in the year, the NI 4051 DVM, which is the Allegro MX DVM. The service, support, and calibrations for that device are ending on December 31st. So you got about a month and a half left. And there's a number of factors that are driving that. One of the biggest ones, to be honest, is it's a PCMCIA device. That's the the PC card form factor. And in today's technology market, it is near impossible to find PCMCA components, and that includes components that are a part of our calibration systems. So as our calibration systems need maintenance, we are unable to find parts to do that. And so we're trying to get ahead of things and just say, hey, we're ending support, ending calibration for these devices. There are replacement products, of course. We've already mentioned those, and they are they are the evolution of our product line. So the Mesa 3 rugged tablet with the DVM 2130, and then the Allegro AX with the DVM 1100, or if you wanted to use an iPad with the 2130, that's another replacement product as well. So you can still, you've got a month and a half left to arrange repair or calibration your 4051s. But after, once the new year starts, that's a service that we will no longer be able to provide. Another set of updates, kind of unrelated to the DVM, that have happened and are happening. The Mesa 3, we have an Android 11 major release that is today. It is actually shipping on new devices. They're new devices that you purchase. Mesa 3s are preloaded with Android 11, and we will be deploying the Android 11. Our target is for next month, December, before the holidays start. And this update has the Android 11 update has updates for privacy, security, features, app performance. When the messaging goes out on kind of the process to do this, which ultimately it's an over-the-air process. It's going to be delivered down to the device. There will be a user opt-in to say, yes, I want to update to Android 11. But when I draft and get out the process to do this, I'll include a couple of links from Juniper Systems, who we kind of purchased the Mesa 3 from, that has more detail about, hey, here are the updates that are within it. In the Allegro AX, we actually had a maintenance release that came out in October, so last month, and that had a number of improvements for connectivity, Wi-Fi connectivity, keypad usability, touchscreen, and that operating system also includes many privacy, security features that that are a part of that operating system. But it does run on a slightly different version of Android, both in revision and in the way that Juniper develops it. But that one came out in October, and if you're using an AX, and you haven't updated to it, it's available to you. And if you have, thank you for taking advantage of that update. And that's all I've got for this morning, but we've got a few minutes remaining where we can kind of open the floor for questions.
Hey, Andrew, I know Ed touched on it, but can you go over the name change on the FTC and Cartapack and what changes and what all that means?
Sure. Let me go back to that slide.
Vince is saying I didn't do a good job on this one,
yeah.
so you go ahead and do a good job.
If I repeat anything,
you did a great job, Ed. But we changed the name a couple of times, so I thought maybe it was worth explaining again.
Sure. So if I repeat anything Ed said, sorry. I had my kind of messaging built on this. So, our vision for the field data collection products really has always been to try and connect the office to the field closer together. And that starts with PCS in kind of delivering your surveys to your device, collecting the data at your device, and then sending that back into PCS, your data, your database of record. So we've always had that vision of, tying these, the office side to the field side. And now with Survey Manager, we are doing that even tighter and wirelessly. So with Survey Manager in the mix, it's PCS wireless sync. So you can wirelessly transfer your surveys to the cloud and then pull those down from the cloud on your device and back the other direction. So we've had this vision of, hey, everything kind of is in the PCS world. Well, why are we not naming the field data collection side within that world as well? So that's one of the big motivations, is to bring that into the PCS ecosystem of products. And that drove the name change for the app, which is now PCS Field Data Collector. It was previously Cartapack Cathodic Protection. It also positions us to be able to do some more things survey-wise and field data collection-wise that may still be within oil and gas, but may step outside of cathodic protection per se. But the idea is that we're bringing it into the PCS world. And then the previous kind of overarching, like, this is for all of the products within our field data collection. It was previously Cartapack Field Integration. Now the rebranding has replaced Cartapack with PCS, because that's really where it's tying into. And so, the idea is that although we have individual products that I'm responsible for, that we sell you, ultimately we're selling you a solution, and that solution is the PCS solution.
Well, that hurt my feelings, because you did a much, much better job. Great work. That was really, really good. So I don't know if you guys picked up on it, but Andrew knows a little bit about calibration. God was especially good to me this morning because he came back at the right time. I don't know how I would have covered the cesium atom quite as well, but Andrew actually joined product management from R&D, where one of his duties was he actually developed our whole calibration system and wrote the code and everything. So thank you, Andrew.
Sure.
And Nick, I see your texts, and I will do that, and I'll send you the receipt to show you that. Absolutely. Thank you for doing that. As you've been to Austin, so you know we have a real challenge helping the homeless. So next virtual brew, December 15th, we will do a Meet the RM5. Hopefully we'll have some slides, but I'm hoping we can actually get that rectifier with the unit and do some real video there. And it should be a really good session. So with that, I hope everybody has a great rest of their week and has a great Thanksgiving next week, where you can spend time with friends and family, hopefully relax and recover a little bit from this hectic world.